Have a look at the next question, dear students. A particle starts moving rectilinearly at time t is equal to 0 such that its velocity v changes with time according to the equation v is equal to t square minus t, where t is in seconds and v in meter per second. Find the time interval for which the particle retards. Options: t greater than half, less than 1, b t less than half, greater than 1 by 4, c t greater than 1 by 4 and less than 1, and d t greater than half and less than 3 by 4. Dear students, here in this problem it is mentioned that velocity is a function of time and we are supposed to find out what exactly happens when the body starts retarding, or in other words, we are supposed to find out the time duration during which the body retards. And it is quite obvious that when the body accelerates, the velocity and the acceleration of the body will be along the same direction. If the body retards, then body continues to move along the forward direction, but its acceleration will be in the opposite direction, or in other words, when the body retards, its velocity and acceleration will be opposite to each other. So, according to our sign conventions, if I consider the forward direction to be positive and backward as negative, if velocity will be positive, acceleration will be negative. If I take their product, the product will be negative. So, here I am supposed to find out the time duration during which the body retards. So, let me say that body retards, as a result of which its velocity and acceleration are opposite to each other. So, their product should be negative. V into A is negative. Its V is given to be t square minus t into, how do I find out its acceleration? Quite obvious, just differentiate velocity with respect to time t. So, differentiating this, I will get 2t minus 1. This should be negative. So, I will take t common here, t into t minus 1 into 2t minus 1 should be less than 0. Look at this, t is always positive. So, the product of these two terms should be negative. So, what does that mean? T minus 1 into 2t minus 1 should be less than 0. So, here I have two options. When A into B is negative, either A should be negative or B should be negative. That is what is the method which I follow right now. So, let me say that in the first case, here there are two cases. In the first case, let me take t minus 1 positive. So, 2t minus 1 will be negative. And in the second case, t minus 1 can be taken as negative. In that case, 2t minus 1 will be positive. So, let me take the first case here. T minus 1 is positive, which is greater than 0, and 2t minus 1 will be negative. So, how do you continue with this? When t minus 1 is greater than 0, t should be greater than 1. T should be greater than 1. Look at the second condition. 2t minus 1 is less than 0, which means 2t should be less than 1, or t should be less than half. What does this mean? This says that t should be less than half and this says that t is greater than 1. Do these two give you the same meaning? They are just contradictory to each other. When t is greater than 1, how can it be less than half? So, the first condition is ruled out because these two results are contradictory to each other. Let us take up the second condition, whereas where I say that this is negative, this is positive. In my second condition, I say t minus 1 is negative, as a result of which 2t minus 1 will be positive. Yeah, t minus 1 negative means that t should be less than 1, and 2t minus 1 greater than 0 means that 2t should be greater than 1. So, what does this result in? T should be greater than half, and this says that t should be less than 1. Is this possible? T being less than 1 and greater than half? Yes, obviously possible. T can be greater than half but less than 1. So, the range of t can be written as t should be greater than half but less than 1. Do I have this option? Yeah, it is option A, which says that t lies between half and 1. So, option A must be the correct answer. Have a look at the next question, dear students. A frictionless wire AB is fixed on a sphere of radius r. A very small spherical ball slips on this wire. The time taken by this ball to slip from A to B is options: root of 2gr divided by g cos theta, B; 2 into root gr into cos theta by g, C; 2 into root of r by g, D; gr divided by root of g cos theta. Dear students, though this looks complicated, it's a simple problem. Here the idea is a very small ball is allowed to slide from A to B, which is inclined at an angle theta to the diameter of the sphere. So it's like a problem of sliding of a body on an inclined plane, for which you need to know the acceleration of the sliding body along the inclined plane. If the acceleration along AC is acceleration due to gravity g, then acceleration along AB should be g cos theta. Okay, this body slides with an acceleration g cos theta, then it starts from rest at point A, then the displacement covered by the body is AB. You can directly make use of the displacement equation S is equal to ut plus half at square, for which the initial velocity is 0, S will be half at square. That S is nothing but AB here. Let me straight away write the displacement AB. AB is equal to half into A into t square. What is that A? Acceleration is g cos theta. So this is half into g cos theta into t square. This is AB, but how do I get the cos theta? Do I have any idea within the triangle ABC what kind of triangle is your ABC? Look at that. It is the triangle made by the diameter, and it's quite obvious that the angle formed by the diameter here at B must be 90 degree, because it is the angle at the half circle. It should be 90 degrees. So in this right angle triangle, you can always define what is called as cos theta. So from the definition of cos theta, this cos theta is AB divided by the adjacent AC. AC is nothing but 2 times the radius, 2r. So cos theta is AB by 2r. I will directly substitute here in the expression for AB. AB is equal to half into g into cos theta is AB by 2r into t square. AB gets cancelled. So I am supposed to find out time taken. So let me write the expression for time taken. So t square is equal to 4r divided by g, and t is directly the square root of the everything. This is 2 times root of r by g. Option C is the correct answer. Let us take a problem on projectile motion, dear students. It is like this. The equation of a projectile is y is equal to root 3x minus gx square by 2. The velocity of projection is options: 1 meter per second, root 3 meter per second, 2 meter per second, and root 2 meter per second. Dear students, this is based on equation of trajectory of a projectile. We know the standard equation of trajectory of a projectile given by y is equal to x tan theta minus gx square by 2u square cos square theta. Compare this equation, standard equation, with the given equation. You will get the value of the velocity of projection. Let me write the expression for the trajectory of projectile. It is x tan theta minus gx square by 2u square cos square theta. Compare this with the given equation. In place of x, you have x. In place of tan theta, you have root 3. Therefore, tan theta is root 3, where theta is angle of projection. I got theta to be 60 degree. Tan 60 is root 3. So, angle of projection is 60 degree. You are supposed to find out the velocity of projection. Velocity is there in the second term. Compare these two values, 2u square cos square theta, 2u square cos square theta is 2 or u cos theta is 1. I want u, which is the reciprocal of cos 60. Cos 60 is half, so u value is 2. It is 2 meter per second. Option C is correct. Take a look at the next question. A projectile has the same range r when the maximum height attained by it is either h1 or h2. Then r, h1 and h2 will be related as options: r is equal to square root of h1 h2, r is equal to 2 times square root of h1 h2, r is equal to 3 times root h1 h2, or 4 times root of h1 h2. Now dear students, this is based on just the formula of horizontal range and maximum height attained by the projectile, and we know that for two different angles of projection the horizontal range will be same, and those two angles should be complementary to each other. If theta is one such angle, then the other angle must be 90 minus theta. I repeat, for theta and 90 minus theta the horizontal range should be same. So the corresponding maximum heights are given to be h1 and h2. Let me say that h1 is the maximum height reached when the angle of projection is theta, and h2 is the maximum height reached by the projectile when the angle of projection is 90 minus theta. So using maximum height formula, let me write the expressions for h1 and h2. See, h is u square sin square theta by 2g. Therefore this is h1 is u square sin square theta divided by 2g. h2, for h2 angle of projection is 90 minus theta, therefore h2 is equal to u square sin square 90 minus theta divided by 2g, and this can also be written as cos square theta. So h2 is u square cos square theta by 2g, and look at my four options. In all the four I have the product of h1 and h2 under root. So let me take their product first. h1 h2 is given by, product of them is given by u square into u square is u power 4 sin square theta into cos square theta, as it is cos square theta divided by 4g square. And what if I take a square root? I am left with root of h1 h2 gives me u square sin theta cos theta divided by 2g, and as you all know, I must connect this to the horizontal range expression, which consists of sin 2 theta in numerator, and it is not difficult for me to write sin 2 theta in numerator. I will just multiply and divide by 2, so which gets me sin 2 theta in numerator and 4g in denominator. Look at this, this can be written as u square into 2 sin theta cos theta is sin 2 theta, so u square sin 2 theta divided by 4g. What is this? U square sin 2 theta by g is your horizontal range, so this term is r, capital R. So I am left with r by 4. So r by 4 is root of h1 h2. I want an expression for r is equal to 4 times root of h1 h2. Option D is correct answer. I will write it out. R is equal to 4 times root of h1 h2. Option D is right answer. Let's take an interesting question, dear students. The Indian cricket coach Anil Kumble, while practicing, throws a ball at Virat Kohli with an initial speed of 20 meters per second at an angle of 45 degrees with the horizontal. At the moment the ball is thrown, Kohli is 50 meters from Kumble. At what speed must Kohli run to catch the ball at the same height at which it is released? Options: 3.16 meter per second, 5.27 meter per second, 0.44 meter per second and 6.67 meter per second. Here let me say that the initial gap between Kumble and Kohli is 50 meter. When Kumble throws ball at Kohli, Kohli should run, I don't know whether forward or backward, that depends on the distance covered by the ball thrown by Kumble. See, when the initial gap is 50 meter, let me first find out the distance covered by the ball and then we'll calculate the distance Kohli has to move towards the ball, and we'll have to find out the time available for Kohli to catch the ball. So by measuring these distance and time, we can calculate the speed of Kohli. So let's first calculate the distance covered by the ball, that is the horizontal range. A small diagram may help you. It's quite obvious. If Kumble is here and Kohli is here, if this is where the ball is released, it follows a parabolic path and finally it reaches Kohli. Kohli actually has run through this distance, and I am now supposed to find out this horizontal range covered by the ball using formula for range, which is u square sine 2 theta by g. U is given to be 20, that is the velocity of projection, 20 square sine 2 theta. Sine or theta is 45 here, so sine 2 times 45, let me write it directly as sine 90 divided by 10. This is 400 divided by 10 is 40. So what does this mean? 40 meter is the range of the ball. The gap between Kohli and Kumble is 50 meter. The distance that ball covers is 40 meter. So Kohli has to run through a distance of 10 meter in order to catch the ball. I hope this is clear. So in order to cover a distance of 10 meter, what is the time available for Kohli? So that is the time of projection, that is the time of flight of the ball thrown by Kumble. So let's calculate time of flight using time formula. T is equal to 2u sin theta by g. This is time of flight, 2 into 20 into sin 45 divided by 10. So this is 4 times sin 45, 4 by root 2. 4 by root 2 is nothing but 2 root 2. 2 root 2 second is the time available for Kohli to catch the ball. So we got the distance to be covered and also the time available. So using these two we can calculate the speed of Kohli, that is velocity of Kohli is given by distance covered is 50 minus 40, I hope this is understood, divided by time is 2 root 2, it is 10 by 2 root 2 is 5 by root 2, 5 by root 2 meter per second, 5 by 1.5 approximately is slightly greater than 3. Do I have anything? Yeah, I have option A, which is 3.16, it is very close to 5 by root 2. So that is the speed of Kohli. Let's take up one more important problem, dear students. At the height 80 meter, an aeroplane is moving with a speed of 150 meter per second. A bomb is dropped from it so as to hit a target. At what distance from the target should the bomb be dropped? Options: 605.3 meter, 600 meter, 80 meter and 230 meter. Dear students, this is very important type of problem. We call it as aeroplane bomb problem. Before we go to this problem, let me discuss one more important thing. If I have two stones, I'll drop one of them directly towards the ground. The other stone, I'll just throw it along the horizontal with a great horizontal speed. And my question is, which of these two stones reach ground first? This answer is very, very important. The answer is both of them reach simultaneously, because when you take the stone, first stone which is dropped directly towards ground, the time taken can be calculated using the formula S is equal to ut plus half at square. Initial velocity is 0, S is equal to half gt square, that is your h is equal to half gt square. So let me write down that h is equal to half gt square. From this I can obtain an expression for time taken. It is always 2h by g under root. This is a very important expression for time taken by the stone to reach ground when it is dropped. But what about the second stone which is thrown with a great horizontal velocity? In spite of giving it a large horizontal velocity, its vertical velocity is 0. Because while discussing the projectile motion, you should ask yourself whether I am discussing the horizontal motion or vertical motion. You have given a large horizontal velocity, but the vertical velocity of this stone is 0. When its vertical velocity is 0, it has covered a vertical distance as well, and it is quite obvious that the path covered by that stone will be a parabola. I think you are familiar with this. If you throw here, if you give a horizontal velocity like this, the trajectory is like this, and this is ground. Let me say that this is the height h from where you have thrown it. This is the path of the stone, and when you consider its vertical motion, displacement is h, initial velocity is 0 as I have explained earlier. Therefore, this second stone should also take the same time, t is equal to 2h by g under root, and this forms the concept of this aeroplane bomb problem. For example, if this aeroplane is moving with some horizontal velocity, and if here is a target, the bomb should be dropped here itself, because when you drop this bomb here, it covers a horizontal distance. Let me say that x is that horizontal distance covered by the bomb. Now my question is, in this problem, what is that distance between this point and this target? So I am supposed to find out this distance between the target and the bomb. So I will have to find out the time taken by the bomb to reach this point and find out this x. X is the horizontal distance covered by the bomb. If I can calculate this x, I always know this height of the plane from where the bomb is dropped. By knowing h and x, you can calculate the hypotenuse. So to find out this horizontal distance, you need to remember one fact, that for a projectile, the horizontal motion is uniform motion, and the displacement along the horizontal can be calculated easily using formula x is equal to horizontal velocity into time. That horizontal velocity is nothing but the velocity of the plane itself. Horizontal velocity is 150 into, what about the time taken by this to reach ground? As I have already discussed, you can calculate using the formula 2h by g. So for the plane, 2h by g is 2 into height is 80 divided by 10 under root. This is 160 by 10. 16 under root is 4 second. So this is 4 second. Time is 4 second, and this will be 150 into 4. The horizontal distance covered by the bomb is 600 meter. But what are we supposed to find out? Don't blindly mark option B as right. The question is not the horizontal distance covered by the bomb. It is the distance between At what distance from the target should the bomb be dropped? At what distance from the target should the bomb be dropped? So, you are supposed to find out the hypotenuse. So, hypotenuse is root of h square plus x square, it is 80 square plus 600 square. So, it should be slightly greater than 600. I think option A comes out to be the correct answer, which is 605.3 meter. So, option A is the correct answer.